So now discuss about the polarization diversity, isn't it? So the selection diversity is a one part, another one is a polarization diversity, other is another type of diversity is like a polarization. So the multiple versions of a signal are transmitted and received via antennas with a different polarization. One is a horizontal polarization, another one is a vertical polarization. There are two types of polarization diversity. The one is a horizontal, another one is a vertical. The diversity combining technique is applied to on the receiver side, isn't it? Whatever it may be the output, so that output we are going to see only in the receiver side. So we are going to see an input in the sense we are going to see the transmitter side, isn't it? So the signals are transmitted through two orthogonally polarized propagation paths, improve like a margin and a capacity. Then the diversity is segregated into two types. Uh, the remaining, the micro diversity as well as the macro diversity. Now the macro diversity, the compact large scale padding created by showing the effect. So the frequency diversity, polarization diversity, spatial diversity, temporal diversity are not suitable here because of all are in a micro diversity. Now we are going to discuss about the macro diversity. So then why is it is not suitable because the frequency diversity, polarization diversity, spatial diversity, temporal diversity are not suitable here. Is the main reason. Then, if there is a hill in between the transmitter and receiver antennas on either the BS or MS stop from the help. It's not a helping one. The macro diversity implementation method. So on frequency repeaters, then simulcast is the main implementation of a method in a macro diversity. What is the disadvantage of simulcast? So the synchronization of all possible receiver is not possible. Each receiver would require the different timing. Then disadvantages of frequency repeaters. The delay dispersion is a larger. The repeater itself introduces the additional delays. In once again, we are going to discuss about the spatial. So the selection diversity. What is meant by selection diversity? So select the strongest signal. What is the select a strongest signal? So is not a strongest signal in the sense is not uses to the selections of diversity. So the selection diversity, if we are going to give it as an input to the transmitter side, so that are three input as channel 1, channel 2 up to channel n. So the channel 1, channel 2, channel n, so it will give a output of a SNR monitor. So what is the use of a SNR monitor? The SNR monitor will give a output of a one because of the SNR monitor going to select whether it is a signal is strong or not. So the is like a not a stronger signal is not suitable for a selection diversity. Why in the sense the stronger signal only can eligible for a selection diversity. So select a maximum SNR of this selection diversity. After that finally we are going to do the receiver. The selection diversity whether it is the signal is strongest or not a strongest. That is why it is called as a selection diversity. Then RSSI received signal strength indication diversity. What is meant by RSS received signal strength indication diversity? R for receive, S for signal, another one S for strength, another one indication diversity. Now here it is used as two antennas, the named as A and B. Now the two antenna A and B are segregated into RSSI. That means RSSI in the sense received signal strength indication. Okay, what is in the received signal strength indication? So the signal strength is weak or not. So if we are going to say the signal strength is we are strong in the sense it is suitable for antenna A. So the simultaneous the antenna B here also selected as a weaker signal because of the antenna A is chosen for a strongest signal. So antenna B is chosen for a weaker signal. So all of the output are going to the demodulator scheme. The receiver selected the signal strength of largest instantaneous power. Finally, the bit error rate we are going to calculate. What is the bit error rate? It is a simply known as BER. The BER, we are going to take it as antenna A as well as antenna B. The antenna A input is selected as RX filter, then the T modulator concept. Similarly, the simultaneously, so antenna B, it will be given to the RX filter of the output of T modulator. So the process is the correlation process, it will be occur. The correlation will be, the output is going to see a lower BER. What's my lower BER? What's my upper BER? The upper BER in the sense the bit error rate is 0 less than R. So the lower bit error rate in the sense the 0 greater than R. So bit error rate is derived by the selection diversity. First transmit the training sequence. Then only it will appear for a bit error rate. The receiver demodulates the signal and compare it with the transmit signal. Then based on the smaller BR, the suitable channel is selected. Now the combining diversity types. The maximal radio combining, equal gain combining. Okay, there are two types. Then the weight all the signal copies their amplitude. That is called as a maximal radio combining. So next one is the equal gain combining. The equal gain combining defined as the signals are not weighted because of but the undergo phase corrections, isn't it? So these are the combined session diversity types.